All right, so this is example 3. And in this example, we're going to explain or show integration by parts, that it's useful also to solve integrands that consist of single terms. Because right now, what are we trying to learn? Why are we using integration by parts? Well, the reason why we're learning integration by parts is to take the integral of an integrand that has two parts, right? Or has two terms multiplied to each other. But you can still use this to take the integral of single terms, okay? So integration by parts is also useful to solve integrands or integrals consisting of single terms, okay? So the integral of natural log of x dx or the integral of arc sine x dx, right? So these are like single terms, see? Only have one term, natural log of x, and here, or the integral of arc sine x. Those are only one terms. So what's the strategy? The strategy is to let dv equal dx. That's the strategy. Let dv equal dx. Okay? So here we go. This says an integrand with a single term. Evaluate the integral from 0 to 1 arc sine of x dx. Okay? So using that strategy, we would let we got u du v dv. So if we're going to use that strategy, we're going to let dv equal dx, and we'll say dv equals dx. So we're going to let it equal this dx right here, right? That means u would have to be the arc sine of x, okay? So that's my u, this is my dv. So arc sine x, okay? Arc sine x. All right. So then now, what is the derivative of arc sine x? Well, if you're looking at your table, your derivative table, the derivative of arc sine of x is just going to be 1 over the square root of 1 minus x squared dx. So if dv is equal to dx, then what's my v? My v is just going to be my x. Okay, because the integral of dx is just x, right? So du is 1 over the square root of 1 minus x squared dx, and v is x. See? So we use that strategy, right? And then we set up our integral. So we want to go the integral from 0 to 1 of arc sine x dx is equal to u times v, right? So it's going to be x times arc sine x, and then we go minus, okay, the integral of what? Okay, of x times du. So it's going to be, I was come v times du. So it's going to be x times 1 divided by the square root of 1 minus x squared dx. Okay? And again, we're integrating from 0 to 1. All right? So there it is. It's set up. Okay? All right? So now, in order to take the integral of this 1 over square root of 1 minus x squared, I have to rewrite this. So the way I would rewrite it is equal to x arc sine of x minus the integral from 0 to 1 of x times 1 minus x squared to the negative 1/2, right? Because a radical is a 1/2. So I'm going to have, so that radical is going to come to the top, and it's going to become a negative 1/2 dx. So all I did was rewrite, okay? That's all I did here was rewrite, okay? So in this video, I'm just going to kind of write the steps here on the side, okay? So the step that I did here was just called rewrite. All right. Now, what do we do here? How do we take the integral of this? Well, what we're going to do is use substitution, okay? So u substitution says let u equal 1 minus x squared, okay? Then that means du is equal to the derivative of that. What is the derivative of 1 minus x squared? It's negative 2x dx. Okay, so, well, I have the dx, I have the x. I don't have the negative 2, so what do? We give it the negative 2, and then we multiply by negative 1/2 on the outside. Okay, so then I'm going to rewrite. So it's going to be x, so it's going to be equal to x arc sine x plus 1/2 times the integral, and then we're going to do our u substitution. It's going to be u to the negative 1/2 du. Okay. Well, what is the integral? Well, what is the integral? So that's u substitution. So I'm just going to write u sub. That's what we wrote. That's what we did there, right? Now we can take the integral of that. What is the integral of negative u to the negative 1/2? Well, remember, when you add a 1 to a negative 1/2, it's just going to become a positive 1/2. So it's going to be x arc sine x plus 1/2 u to the 1/2 divided by 1/2. And I'm just going to put this in brackets because I'm taking the integral of that, right? And remember, it's from 0 to 1, so I'm going from 0 to 1 when I'm taking the integral. Okay? Now, good news, this 1/2 on the bottom cancels out with that 1/2 here on the outside. Okay? So I'm going to plug back in my u, and I'm going to just rewrite it again. So it's going to be just a lot of rewriting here. X arc sine x plus my u is 1 minus x squared to the 1/2. Okay? But you know what? Let's put it back in radical. Instead of 1/2, we know that 1/2 means square root. So I'm going to go square root and then put it in brackets from 0 to 1. Okay? And now we can evaluate the 1 and the 0. All right? Now, okay. Now let's do this. Forgive me. Instead of putting that bracket there, we just might as well put the bracket around the whole thing and evaluate from 0 to 1. Okay? So let's start with our 1. Well, we plug in 1. It's going to be 1 arc sine of 1 plus the square root of 1 minus 1 squared, which that's going to give us a 0, right, for that radical. We'll deal with that in a minute. Okay. Minus parentheses. Now we're going to evaluate the 0. So it's going to be 0 times arc sine of 0 plus the square root of 1 minus 0 squared. Okay, on parentheses, and this whole thing is in brackets, right? All right. So remember, now arc sine of 1. Remember, arc sine of 1 is equal to theta. So we can rewrite this. So what is that? Well, if you just rewrite it, that's the same thing as saying sine of theta is equal to 1. Okay. Well, the only theta that I know where sine theta is equal to 1 is pi over 2. Pi over 2 is when is the point 0, 1. And this 1 right here is my sine theta, right? And the 0 is my cosine theta. So theta has to be pi over 2. So that means bracket, parentheses, this is going to be pi over 2. Okay? So this right here, let me just write it in red here, is pi over 2, right? Pi over 2. Plus, well, this is the integral of 0, okay? All right, 1 minus 1 squared is 0, so that's just going to be 0 here. And the integral of 0 is 0, right? Parentheses, and then go minus, parentheses, and then now 0 arc sine of 0. Well, that's just 0 times arc sine of 0 is just 0, right? Because I'm multiplying by 0 here. So we can really care less about the arc sine of 0 and what that is. Correct? And then the square root of 1 minus 0 squared is just the square root of 1, which is just 1. That's going to be a plus 1. So I'm talking about this piece right here is going to be that 1, right? And that little dot right there shouldn't even be there. And we put the brackets, and we're ready to go, class. Well, pi over 2 plus 0 is just what? That's just pi over 2. And minus, and 0 plus 1 is just 1. Okay? And that's my answer in exact form. We just need the decimal. Pi over 2 minus 1 is approximately 0.5. 0.571. And that's my answer. Okay? So therefore, the integral, so what did we found? We found the integral of arc sine of x dx from 0 to 1, right? And this is an integrand with a single term. So to do this, we make u to be our arc sine of x. Well, the strategy is to let your dv be dx and the other portion to be your u. So we let u to be our arc sine of x and dv to be dx, and you can do this whole integral using integration by parts. Okay, so this is how you do example 3.